In this video, we're going to be taking a look at simplifying rational expressions from Khan Academy. This time we're focusing on the section that asks you to factor out using common binomial factors. If your website is showing an expression like this, let's keep in mind that there really should be a fraction bar in between the two. And when we're factoring a rational expression, that's simply a factor or a factorization of our numerator, which is made up of a polynomial, and our denominator, which is made up of a polynomial. And we're ultimately going to look for common factors that can be removed. Now, we can only remove common factors if those factors are separated by multiplication signs, not addition signs. With all of these terms here, even if we had some, say, n squareds in the numerator and n squareds in the denominator, we don't dare cancel anything yet because we haven't gotten our terms separated by multiplication signs. This term, 3n squared, is separated by 15n by an addition sign. We can't have that. So I'm going to kind of jump over this text box here, and I'm going to focus on this numerator. It's a standard trinomial, which means its leading coefficient is 1. We have a 1n squared, and that's what makes this a standard trinomial. And with standard trinomials, we try to find a binomial pair who leads with the variable. That's nice about all standard trinomials. And then we look at this trailing term, and we try to find two numbers that multiply to make this term. They multiply together to make this term, but the same two numbers will either add or subtract to make the coefficient of this middle term. And so you might recognize that 3 times 3 equals 9, and positive 3 plus 3 will add together to make 6. And so this looks like a good factored result for our numerator. We could check that, of course, by foiling back together, and if we foiled n plus 3 times n plus 3, after we combine our like terms, we'll be back to the original expression. Now in the denominator, I'm going to check for a greatest common factor first, because if we can get a greatest common factor out of here, then we might be left with a standard trinomial. Otherwise, we'd have to factor a non-standard trinomial with a leading coefficient other than 1, and that can be kind of difficult. There are lots of techniques that can be used to do that, but generally they're more challenging than others, and I try to avoid that if possible. So as it turns out, each of these three terms is factorable by the number 3. That's our greatest common factor. So I'm going to factor that out of the group, and after I divide this first term by 3, after I factor by 3, I'm left with n squared. After I factor or divide by 3 in the middle term, I'm left with 5n. And after I factor or divide by 3 in the last term, I'm left with 6. Now, I don't see any common factors in the numerator and the denominator yet that are separated by multiplication signs. In fact, we have two terms in the numerator, and now in a sense, we have two terms in the denominator that are separated by multiplication signs, and none are common across the numerator and the denominator. And so, as is the case, often we can continue to factor until we're fully simplified. Now, the numerator, there's nothing we can do there, but in the denominator, we're left with a standard trinomial. Again, with a standard trinomial, we know that n times n will give us n squared, and we're looking for two numbers that multiply to make 6 that also add or subtract to make 5. There are two numbers that I can think of, either 6 and 1 or 2 and 3. The choice that I want to make is 2 and 3 because a positive 2 and positive 3 will add together to make positive 5. If we had chosen 6 or 1, or 6 and 1, well, we would need a positive 6 and a negative 1, which 6 minus 1 does equal positive 5, but positive 6 times negative 1 equals a negative 6, which is not what we have here. When we factor, there's only one result to correctly factor a trinomial. If there are multiple combinations that look like they might work, make sure you double check and verify whether or not you're choosing the correct combination with multiplication and division. Now, before I simplify, let's point out that this factored form of the expression is still the same as this non-factored form of the expression over here on the left. And so it's at this point that I would identify my excluded values, or the values that make the expression undefined. So we don't want to allow n to be -2, and we don't want n to be equal to -3. If n were to equal -3, then substituting it into this expression, or this expression here, would make that entire expression equal to 0. We can't have that 0 in the denominator. Additionally, that number -2 would do the same thing with the other term. And when -2 gets substituted here, it turns the entire expression equal to 0. When we substitute it here, it does as well. So those are our two excluded values, but now, finally, if you saw this and were waiting for me to do so, now's the time where I would cancel out these factors. Because here finally we see that we've got two terms in the numerator separated by a multiplication sign. Essentially we have three terms in the denominator that are separated by multiplication signs, and only when our terms are separated by multiplication signs can we cancel common factors. We finally have that, and with the n plus 3 gone from the numerator and the denominator, we're left with an n plus 3 over 3 times n plus 2. If we tried looking for our excluded values, or the numbers that make the expression equal to 0 at this point, at the very end here, well, we'd only see one of our exclusions. But I can assure you that the site and a proper mathematician would find all of the values, done so here at the factored step. And off screen I did punch those into the website and accepted that answer. So hopefully this helped you out and gave you some clarity on this type of problem. If you have further questions, please let me know. Thanks for watching.